And with that, we'll get underway. So thank you so much for being here. I'm really excited to have you. Really appreciate. It's always just like so fun to reconnect with a lot of you all. I know some of you all have been in a class with me. Some of you might have just found me randomly through YouTube or however the world connects people these days. And I really appreciate you all being here. And I know I'm going to miss people that I should shout out in saying this, but I also really appreciate the groups that I could tell, we're trying to encourage a lot of their folks to be here. Like I've seen there's a bunch of people from Seattle colleges and Stanford Children's, Nebraska Med, South Central Foundation. So appreciate you all making the effort to get the word out and that people listen to you. So I guess that means you have some clout at your organization getting people to sign up. So let me do a little bit of an introduction about what this webinar is going to be about. I'll do a little bit of a personal introduction too, in case we haven't gotten a chance to meet in a live environment. And then we'll get rolling here. So Tableau relationships versus joins. Grateful that you're here. The presentation that I'm giving and the work that I'll be doing is in Tableau Desktop version 2021.3. I just wanted to call that out at the beginning for a couple of reasons. If you're in an earlier version of Tableau Desktop, some of the features might be slightly different, or there might be like limitations that you have that won't show up with mine. And if you're watching this later or you update to a new version soon, I don't know what the future holds. So there might be differences, or I might speak to something that's a limitation now that might not be in the future. So let me do just a quick personal introduction. So my name's Eric Parker. I live in the Seattle area. I've been working directly with Tableau since 2014. I actually teach a lot of their classes for them. Like if you take a class directly from Tableau, you might get me. I also teach independently, and I do kind of contracts and projects as well. So kind of get my hand in a bunch of different pots. And I work primarily with Tableau tools and some related tools like Alteryx as well. And then something that I try and do is just kind of pay it forward through teaching others. So not only in classes, but doing things like writing blog posts, shooting videos. I put this in like air quotes, doing quarterly webinars, because I think this is the first one since like June. So it doesn't always quite end up being quarterly, sort of depends on what's going on in life. But I try and do at least a few of these a year on big topics that I feel like deserve a deeper dive than I'm able to do in a 5 or 10-minute video. And so you might have actually already noticed that this webinar is kind of an exception to how I normally do things, in the sense that typically I like to keep webinars to 30 minutes because we've all got a lot going on and we all have shorter concentration spans than maybe we used to in the age of smartphones. But I knew there was no way that we could do this conversation about relationships versus joins. I knew we couldn't do it justice in just 30 minutes. So if that's all you have, that's still great. I'm excited you're here, and you might be able to catch some of it later. But we will be doing a pretty deep dive today. So along the way, if you have questions, definitely feel free. I think the best way to handle those while we're kind of in motion is through the questions dialogue in the GoToWebinar chat. At the end, I'll do like hand raise and try and unmute people. Unfortunately, just with so many people, it will be really hard to do that like midstream, because we might only like get through 10% of what I'm thinking. So feel free to ask questions along the way. They might be things where we're going to handle them anyways, and I'll just kind of keep carrying on. I might stop and address something. My colleague Kirk is on the line, so he'll help as well and respond to you in the questions dialogue if it's something that he can help with just over the chat. Okay, so just to kind of give a little background on why did I care to put this webinar together specifically. So Tableau's relationships feature has been out for like about 1.5 years now, and there's a lot of resources about it, but I feel like my experience with them is that they're kind of scattered. Like you can read through 10 different blog posts and pick up 1 or 2 things from each post, but I had a really hard time finding like one comprehensive overview that tried to cover all of the bases of like, what is this thing? How does it compare? Which scenarios are right for joins? Which ones are right for relationships? And so, to be honest, almost more out of like obligation rather than excitement, I originally started to build this webinar because I was like, I feel like this needs to be out there. Somebody needs to make it. And I mean, I teach classes that focus on relationships, and I just felt like I was selling people short just doing a 15-minute conversation about them. And so I'm going to be very frank with you. I came into it being set in my ways and kind of feeling disparaging toward this feature and just being like, why would I want to change the way that I do things? You know, just basically just being an old dinosaur. And I actually feel like in researching for this and doing a lot of experimentation, my tune has changed quite a bit. There are certainly situations where I probably wouldn't want to use relationships for, but there are also a ton of situations where I could see that they'll probably be more beneficial than joins. So I'm just going to kind of leave that as our intro, and then we will go ahead and dive right into this. So let me start by giving a bit of a backdrop for joins, and we'll talk about some of the pros and cons of joins, and then we'll get into the relationships piece of this. Okay, so I'm going to kind of give a definition on joins, but I think it's fair to say that the way I've set this up also does assume a little bit of familiarity, like hopefully it's something that you've touched on before. So joins are an operation which allow you to take two tables and relate their rows together so that you can create sort of a horizontal connection. So for instance, when you join two tables, I just did a really simple diagram here. So I've got these 5 rows and these 2 columns, and then these 5 rows and these 2 columns. Like the output of this join example is now a data set with 5 rows but 4 columns. So typically speaking, the output of a join is going to be, it depends on the join type, so I guess I want to be careful how I say this, but it's going to be essentially adding the 2 pieces together to create, you know, maybe a larger output. So some just quick things to know about the way that joins work. First of all, they're visualized in Tableau as a Venn diagram. Which sections and which colors of the circles are drawn in on the Venn diagram indicate what kind of join that you've created. So you can do things like left joins or outer joins. This was Tableau's default nature for connecting 2 tables of data horizontally in Tableau Desktop 2020.1 and earlier. So if you've upgraded to 2020.2 or later, you're now probably seeing relationships as the default approach, although joins are still available. We already talked about the Venn diagrams part. So something that sets joins apart from relationships is a join. You set it once, like at the beginning of the workbook, and you could go back and edit it, but you set it once, and then whatever the structure is that you created is the same across all worksheets that use that data source. And sometimes you'll hear Tableau use this language of like physical layer versus logical layer. Joins are referred to as the physical layer because of this situation here, where you're taking the 2 tables and the sum is essentially the addition of the 2 parts, if you want to think about it that way. Okay, so that's a little bit of a backdrop. So let's jump into what are joins good for and maybe what are some of their weaknesses. Okay, so joins, one thing I really like about them is somebody who doesn't know Tableau that well can jump in and they hear the term join. If they've done a join before in, let's say, SQL, the concept is very similar. So there's not really much new learning that needs to happen. You just have to kind of learn the interface. Joins allow for type selection, which is to say that you can take 2 tables and you could create an inner join, which is to say you're only keeping the rows of data that found a match in the other table. You could do an outer join, which keeps all rows of data, you know, it makes all the matches possible and keeps anything that didn't. And then there's left and right joins, which ensure that at least all of the data from one table is kept when that join is created. Joins, I guess I would say joins and unions. They can be good for handling complex situations where you have multiple fact and dimension tables. We'll define those in just a second. And one thing you don't have to worry about with joins is that if somebody's using an older version of Tableau, they can, you know, if they you know, access your data source or something, it's not going to be affected if they're in like 2019.4 because joins were available back then too. Downsides of joins, they can duplicate data unnecessarily, especially when you have situations if you relate to fact tables. again, more on what exactly is a fact table here in just a quick second. There can be unnecessary performance drag as a result of unnecessary duplication, or if you have a situation where you have tons of tables that are related and you're only using like a couple columns from each of them, but now your data source is 100 or 1,000 columns. And we're just going to touch on this part briefly, and I'll link out more materials for this. If you're using a row level security in Tableau, meaning like you're restricting access to data based on what site or what area or what department that somebody should be able to see, the sort of default method of creating that row level security will blow your data source up before filtering it down for the user. And that can also have performance implications. So let's dive into this. So start going through some examples now. Actually, you know what? No, I'm going to bounce around on this just a little bit. So fact and dimension tables, I mentioned that we would define those because they're things that we're going to see a few times throughout this webinar. So these are sort of database vocabulary terms. So if you're connecting to data directly in a database, often you will see data stored in one of two formats. A fact table mostly has measure or numeric-based information that you want to analyze. And dimension tables typically have like descriptive dimensional information. So a lot of times a dimension table would be taking an ID and then converting it into more meaningful information. So converting an employee ID into an employee name, a store ID into a store name or location, that kind of idea. Okay, so let's start by talking about some of the positives of joins. And we're specifically going to focus on things that maybe joins can do that relationships are either can't or are not as strong at. So first of all, type selection. So joins allow you to pick left, right, inner, or outer. Sometimes you want to pick a specific join type in order to filter your data. So for example, let me go ahead and just double check this data source here. A lot of these data sources are pretty simple, just for the sake of example. So this data source has two tables. I've got monthly sales, which is just, I think just sales throughout the month of January 2018. And then I have a store ID or store table that converts the IDs into some information. So first of all, right now I can tell that this is going to try and get me to build a relationship because I've got the gray monthly sales box. If I want to do a join, I can hit the drop down next to that and say open, and this will move me from the logical layer to the physical layer. Your main cue there, hey, you got color. So you can tell this came from here. Okay, so I'm going to go ahead and join the monthly sales to the store table so I can tell maybe what store these sales came from. And it suggested the join that I would want, store number equals store number. And in this case, if I use an inner join, that will make sure that I'm only pulling back store information that had monthly sales. So there would have to be a match between the store number in the left table and the right table. So flipping back over to my worksheet, give me a second here just to make sure I've got the right thing going. I think so. Oh, okay. Actually, it was more subtle than I thought. So I think it just knocked out a few a few stores. So you can see previously store 102 was here, but that's gone. And there's another one. Yeah, store 107. So I probably should have picked something that popped out a little bit more visually. But the idea here is that those stores didn't have sales. I think if we look more closely, they might have even been closed. I don't know. I think that it says that somewhere. But basically, we use these joins to be able to filter our data. So because the stores that were closed aren't showing up in that store table anymore, I was able to cut the number of rows on this worksheet down. So that's a pretty specific use case, but there might be times where you want to use a join to effectively filter your data. And joins can do that, and relationships, it's a little different. We'll get into it. Okay, so let's look at another situation where joins might have a leg up on relationships. In that situation where that's a situation where you have multiple fact tables and multiple dimension tables. Okay, I made notes to myself to remember which data sources to go to, so give me a second here. All right, so this is a kind of involved situation, right? If you work with data in a database, you might have similar things where, hey, I got to get the sales and the employee and the items and all of that. So in this kind of situation, I don't know. I think that relationships, depending on the complexity, could handle this, but joins might be better. So for instance, I'm going to open this up. So I've got basically two fact tables, and that's sales, right? That has numeric information about stuff we sold. And then we've got hours worked. And then our dimension tables would be like employee ID, items, store. And we're going to get to this one a little bit down the road, permissions. So as kind of a general rule, with joins and unions, you typically want to union fact tables together and join dimension tables. So what do I mean by that? So I have my sales information. I'm going to union hours worked to sales. So now I've got two tables here, which are only loosely related, right? I don't want to join hours and sales because I worked an hour and like that doesn't, I don't know. There's maybe a little bit of a relationship with sales that happen, but it's not a one-to-one. Like I worked 1 hour, I sold one thing. Like I might have sold 10 things, I might have sold 3 things. So now I want to join some different tables to this. So like employee ID, I can now join that to the union tables. That's really only applicable for the hours worked. There's no employee ID record for we sold a cheeseburger. But there is an item ID for that. So I could join the item table. And I'm doing left joins because I don't need to get into this in too much granularity, but I basically have 2 tables represented here now, one for hours and one for sales. So for one of them, it would relate to this and another one would relate to that. But I don't want to lose information just because there was no item associated with how many hours I worked. And lastly, I think store should relate to all of them. So, okay. So this is a good situation for joins to be able to handle because I've got the multiple fact tables, because I need to link out to all these dimension tables. So flip back here. So now if I wanted to say on a given day for a given store, how many hours were worked and how much did we sell? I now have the flexibility to be able to do that with this sort of, super data source that I just created. So give me a second here. So there's my store ID, again, just kind of simplified data, just a single store for now. Got one day, and then I should be able to see, I think this is sales amount. So $1,700 and 42 hours total worked across all employees. So there you go. That company's probably not doing very well because they're only making $4 per hour worked. But I think our model worked without going into too much of a rabbit hole on it. Okay, so let's look at some situations where maybe joins don't stack up as well. So one of those we talked about is that joins don't always, they don't do very well at relating multiple fact tables. So an example of that, let me go ahead and dig into this accident log data set. So this data set's just made up of 3 primary tables. I have an accident log, which basically just says on this day, this accident ID happened at this location ID. Okay. The location ID ties out to a street name. So location 5, for instance, can be found here in the location table. So that would be Derrick Street. And then I've got a different fact table, which is the average daily, vehicle traffic on a given street. Okay. So if I wanted to know, how many accidents are happening on these streets, over this time period of the accident log, and what's the average daily traffic of those different streets. So let me go ahead and open up the accident log, right? And so if I try and join these together, so I take the accident log, join to the daily average traffic, So sure, they both have a location ID. So, okay, yeah, in theory, like you could join on the location ID, but here's the problem. Daily average street traffic just has one record per street, like Derrick Street, one record, and it tells you how many it is. But the accident log might have 5, 10, 50, 100 accidents that are represented on that street. So what happens in a join like this is if you have one row of data in the left table, or I'm sorry, accident log could have more than one. So let's say that you could have 5 records here in the accident table, and you only have one matching record in the daily average street traffic table. What it does is it ends up creating every possible combination. So this one row from the right table just got multiplied out 5 times. So if it said the average traffic was 1,000 vehicles, well, now Tableau is going to default to summing, and excuse my chicken scratch here, but it's going to say that you have 5,000 average vehicles on this street, which is not true. That's not the daily average. That's adding a bunch of them together. So this is a situation where you can handle this down the road in Tableau. You can use aggregations or level of detail expressions, but it's not like idealized. So let me set this up, get our location ID. Everything should find a match, so it shouldn't matter whether it's an inner join or not. So just to show you what I mean now, if I get my location name, I'll just put the location ID in there in case there's any, I don't think there's any duplicate street names, but just to be safe. And then if I looked at, let's see, count distinct of accident ID. And then let's go ahead and drag average daily vehicles out there. So this average daily vehicles, so this is actually this number here, because it defaulted to sum, is actually 11x what it should be. So if I swapped this to be the minimum aggregation, that's the actual number. Oak Street has 1,700 daily vehicles. So again, thinking about the aggregations, you can handle this using level of detail expressions. You can try and keep this stuff from duplicating, but a few things are happening. First of all, the duplication is happening regardless, so that can have some performance implications. And then you'd be covering it up with a level of detail expression, which is another performance implication. So we've actually duplicated and then aggregated at it. If we did what I mean by the level of detail expression is if I don't ever want to see that data duplicating, I could say like, fixed average daily and say something like this. So fixed on a location ID, give me my minimum average daily vehicles. So this makes sure it's not going to duplicate. It's just going to relate the minimum value of this to the location ID. So that works. That should, in theory, keep that from happening. But I've just solved one problem by slapping by slapping a solution on top of it that may end up also having performance implications. So at scale, this may not be like the most effective way to relate this data. And you might kind of see, again, performance drop-offs because of that. Okay, so a couple more ideas that are kind of maybe downsides of joins. One is that when you join a lot of tables together, what the join does until you go hide things or exclude them or do some sort of custom SQL is they bring all of the columns from every table. So you might have 5 or 10 different tables that you're relating, and you're really only looking for a couple components from each of them, but the join is grabbing all of them. So in a super extreme situation, like I was working with a client who joined together 25 tables, and they had 1,500 columns in their data set. And they were like, hey, we made an extract. It's only like 12,000, 15,000 rows. Why is this thing being slow? And I was like, well, it's because there's so many columns. So I did like an extract where I hit all the unused columns. They were only using 40 of the 1,500 columns. So one of the beauty of relationships is that it's not going to be unnecessarily like pulling in columns you don't need. I will show that here in just a little bit, but basically relationships kind of intelligently figure out, oh, this is the fields you've used in this worksheet. Let's just get that information, as opposed to grab all 1,500 columns and bring it over here and just create this huge data source. So that's one of the downsides of the physical layer, is that it adds all the columns and all the rows into it, or at least as many as are applicable based on your join clause. All right, so I don't want to dive too deep on this one, but maybe just as like kind of a quick informal poll from you, can you give me a raise of hands if you use some sort of row level security in Tableau? And so what I mean by that is maybe you or somebody else curates a table that says like, oh, Kirk can see store 100, Sandra can see store 101, but Derek can see any store, you know, that kind of thing. Okay, so yeah, there are at least a good number of you that, you know, you have a setup like that. So the traditional way of setting up row level security, let me see if I can find this, restaurant sales hours words. So we're gonna revisit an old friend of ours here, this data set with the restaurant sales and hours. So I've got a table here called permissions. And in this case, again, this is just a very simplified example data set, but I am just one of 4 people that can see information for store 200, okay? So as of right now, this data set is 200 rows, right? So in your sort of typical, what's what I'm looking for? Your sort of typical row level security setup, try and get back over to this. You know, let me get this data source going here. So let's say I'm like, oh, you know, here's my store, and let me just do number of records. Oh, they're gonna make me go with count. More on that later. Okay, so this will show us, is that right? That seems weird. Didn't it just tell me it was 100? Yeah, okay, hold on. Hold up. I'm just gonna create a calculator. I'm just gonna go with the old number of records from scratch approach here. Okay, fine. It's 107 records. So I'm going to go back to the data source tab. Don't know why I got that extra 7. Oh, maybe maybe this is the preview. Tableau, why you be changing things on me? I didn't realize they changed it from 1,000 to 100. Learn new things every day. Okay, so now we're up to 107 rows. And so if I add the permissions table in here, like, I'm just going to keep this brief. I don't need to go into like, you know, untold amounts of detail, but because there's 4 different people that have permission to this data source, that 107 just got multiplied 4 times. So now we're up to 428. And then you know, there's a number of ways of doing this, but one of the ways that you can control for who has access to this is I could add a data source filter. And I'm going to do this based on, I think it's this email field. And so I'm going to say, you know, the grantee email needs to equal the active username of whoever's currently logged in to the Tableau server. So if I do that, well, it's me. I'm logged into the Tableau server, right? It knows it's me. I'm signed in through Tableau desktop, so it knows. So once I apply this, we're back down to 107, right? So what happened? Okay, so we had our table, we blew it up a bunch of times so that everybody could have access, and then we filtered it back down. Does anybody see any reason that we might have some performance issues with this, right? Like, oh, okay, take it, blow it up, bring it back. It's like, at scale, that might be a really ineffective way of handling permissions. So there are workarounds for this. You know, like I've had situations where I pivot the names, create one long list, and then you have like Eric, Chad, Janice, and then you can search within that list. Yeah, there's kind of workarounds, but they're, you know, improvements on performance, but they're maybe not the best way to set up. Okay, or the best way that we had before relationships, I guess I should say. So that kind of covers it for the joins section, where we're going to be looking at the pros and cons there. So we got to see a couple things they're good for, and a couple things where maybe they drop off a little bit. Give me a second here. I'm going to take a sip of water, and then we will dive into relationships. Cool. And thanks for the questions along the way too. I'll be trying to dig into that. But yeah, for those that maybe joined a minute or two late, we're doing a recording of this. So it'll be something where hopefully in the next couple days, you'll have access to it again if you want it. Okay. So let's set the backdrop for relationships. So relationships, Tableau describes them as an operational contract between multiple tables, which allow for related elements to be brought into a worksheet together. And so how that relationship is defined is, so you set some matching fields, you set a criteria for how those fields match, and then Tableau uses a worksheet to figure out how would I grab which fields I need for this. So that's kind of in the quick fact section, that's something that makes relationships super different from joins. Joins, it's kind of like you do that first and then you do everything else. Relationships, you set up how a couple tables relate, but which fields are relating and what that looks like varies from worksheet to worksheet. Okay, so for instance, kind of going back to our joins intro slide, in joins, we were just like, this table plus this table is equal to that table. That's how joins work. Relationships, after you set up which fields can relate and how that works, you really want to think about it like starting with the worksheet. This is my worksheet. What information is this worksheet asking for? Oh, it's asking for some information from this table and from this table. Specifically, what information from those tables is it asking for? Oh, it's only asking for these two fields, so we only really need to relate the tables at this level. So maybe let me zoom in there so you can actually see that. It's a little grainy. But here, like, okay, there's a region field, but we're not referencing region at all in this worksheet. So, okay, who cares? Then forget about region. How do these categories relate to these categories? And then what does that relationship look like? So something that makes these relationships unique is they can sort of relate data at different levels of granularity based on what you've asked for in your worksheet. So you really want to think of relationships again as kind of leading with the worksheet and then going back and getting whatever data it needs and relating it at the level applicable based on what fields you use. Okay. So a few quick facts here. First of all, this is now in 2022 and later, this is now Tableau Desktop's default method for connecting two tables horizontally. They're visualized as noodles, right? So if you just see kind of like a gray or an orange line between two tables, as opposed to the Venn diagram, you know that you are looking at relationships. Like we just talked about, relationships are much more driven by the worksheet. So you can think about them as kind of a worksheet specific or worksheet dependent model. And Tableau calls this the logical layer because, again, in a join, like these two tables, if we join them, the result would be the sum of the individual components. With relationships, it's more flexible than that, right? Depending on the worksheet, the result might be not bringing in all that same level of information. And that is exactly what makes this this process, this new method, kind of difficult to define because it is in flux, because it's flexible. I can't just give you a quick rule, 1 + 1 = 2. I'm like, it depends. 1 + 1 could equal 1, or 1 + 1 could equal a half, or it could equal 4. Like, I don't know. It depends on how you set that relationship up. So let's go ahead and start talking about why you should care, right? Because I think to be frank, my approach for most of the last year and a half was I can do what I want with joins. I don't care about relationships. And so at first I was kind of like, okay, why would I care? And so then as I've gotten more into it, though, I've realized that there are some pretty serious situations, maybe performance considerations, where relationships can help a lot. So one of the most common questions I get from people is, okay, if relationships are kind of like joins, what join type are relationships most like? And I used to just give people an answer like, oh, they're most like a whatever join. And now I'm like, haha, it depends. So let me start by looking at a data source that we're going to use to be able to look at essentially different join types that you can create with relationships. So I've got a data set that's got a few weeks worth of data from a chocolate shop and a few weeks worth of data from a pub, and supposedly the same owner. So these data sets are pretty related. They're open on a lot of the same days, but not exactly the same days. Each of them is closed 1 day a week, but those days are offset. I think the pub is closed on Sundays and the chocolate shop is closed on Mondays. And when one of these stores is closed, there's no record of data for that day. It's not like it says 12/8/21, 0. There is no 12/8/21. So just to take a quick glance, why did it go there? So quick glance at the data we're talking about here. So here's our chocolate shop sales. So if we kind of zoom in here, we'll just see that every once in a while, there's just basically a missing day, right? Like 11/12, 11/19. So once a week, there's just a missing record. Now Pub does something similar, but it's just different days that are missing. Right, so here we do have 11/12, but we're missing 11/13. Or here we do have 11/19, but we're missing 11/20. So you can see how this could provide kind of an interesting use case, right? They share a lot of the same days, but not all the same days. So I know some of you are already thinking, just union them. Okay, yeah, I know we could, but I'm doing a simplified scenario for relationships. So let's pretend that unions don't exist for a moment. Just suspend reality with me. So if we relate those two tables together on the date field, give me a second just to actually do that, right? So if we had our chocolate shop and then I brought pub sales in, and then I said, yeah, the relationship is that the date field should equal the date field. Okay, right? So unlike joins, I don't say, well, give me an outer join so I don't lose any sales. I don't have the flexibility to do that. I just say that should equal that. More on some of these other options here in just a moment. So then what kind of join that these would resemble is very much dependent on what fields I use in each worksheet. For example, if I only use a dimension from each table in the worksheet, but I do not use a single measure, the worksheet is going to resemble an inner join, okay? So again, no measures in play, just the date field from each of those. Notice that not only both the 12th and the 13th are gone. Both the 19th and the 20th are gone. So this is effectively resembling an inner join. Okay, what if I use a measure from both fields? Cool, if you use a measure from both fields, the relationship is now resembling an outer join, right? So notice, I mean, the data is all kind of messed up here, but basically we have the 12th, it only shows up in this column. We have the 13th, it just only shows up in this column, but not here. But I have everything here. So maybe with some calculations, I could get a single date column and a single sales column, so it looks clean, but everything's there. So when you are using a measure from each of the two tables, again, you're basically getting, more or less an outer join. What if you're only using one measure? Well, if you're only using a measure from one of those two tables, you're effectively creating, however you want to think about it, like a left or a right join. So for instance, this is just using the chocolate sales data, or just the chocolate sales measure, I should say. It's actually got both dates on it still. So we are still missing days. For instance, I do not see a November 12th because I assume the pub was closed that day. I'm gonna be completely honest with you. Like I only found, I knew like about parts of this. I only found out about this in kind of the entirety that I just showed you in preparing for this webinar. That's one of the reasons I like to do these, is because it forces me to learn new things. So let's recap. What kind of join type does a relationship resemble? It depends, right? It could be an inner join if you're just using dimensions. It could resemble an outer join if you're using measures from every table. Or if you're just using a measure from a single table, it's going to more or less resemble a left or a right join. If that's the only thing you get out of this entire webinar, I still feel like I'm glad you joined, and it was worth my time to spend however many ridiculous amount of stupid hours that I spent preparing for this. Okay, so let's dive into it now. Why does this all matter? Okay, we can see that there could be some upsides to this. Based on what I just showed you, you might be thinking like, I don't know, might be losing data. So let's talk about let's start with the good, right? What are relationships good at, or what are they good for? They could help you with performance improvement, okay? So for example, if I go into this data source here, sample superstore, this basically, I have three tables here. Orders is like sales and transactions. We sold a chair or a couch or a table, whatever. People tells us who is the manager of each region. And returns tells us, it's a subset of orders. It just tells us if an order was returned. So orders might be 10,000 rows and returns might just be 500 or however many of those were returned. So there's not too much wizardry here in relating these. I think that they kind of guess at the right values. Order ID equals order ID. For people, I think it's going to be like region equals region. So here's one of the ways that relationships may help you from a performance perspective. If you go into the performance options, you have the ability to set the cardinality and referential integrity of the fields. So that sounds more intimidating than it really is. This is basically just saying cardinality. Okay, an order ID can show up more than once in this table because if I bought socks and shoes, that's 2 rows. But a return is only going to be listed once, just a weird data set. So they're just like, oh, if I return my socks, hey, this order ID got flagged as returned. So in this case, an order ID could show up many times from this table, but there's only going to be one order ID record in returns for each order ID. And then, yeah, I'm not expecting every order ID to get returned. So only some of those records would find a match. But every record in the returns table should find a match, right? In order for an order to get returned, it had to have been placed. And if it was placed, it should be in the orders table. So this is going to help Tableau in relating these tables because it knows better the rules for how these tables relate. Oh, that could match only once, that could match several times. This should find a match in every situation, this shouldn't. So like if you think about it, like this isn't exactly how processing works, but if you think of a person like behind the screen, like, did this record find a match? It did. Okay, cool. Are there any more matches? Right? Like that's kind of what the computer's doing. So if it finds a match and you tell it should only match once, it's done. It doesn't have to search for that row ever again. It gets to move on to the next one. So the cardinality and referential integrity can help with performance just strictly because you're giving Tableau better directions for how those two tables relate to one another. Okay, another pro of relationships is you probably don't need to do as thorough of planning for relating tables, multiple fact tables. Okay, so going back to our accident log data source, I've got a second copy of it. So in this case, accident log, right, that's just one record per accident ID. And now I'm going to relate that to our daily average street traffic. They're going to relate on location ID. For the sake of time, I'm not going to do performance options going forward, but I could go in there and say, oh, this should be a one-to-many, and that would help. And now location ID ties out. Okay, so now, unlike before where we had to be like, give me the minimum value or give me a level of detail expression, now I can just say, okay, give me my location ID and my location name. Tell me, average daily vehicles. Notice that that's like 1,700 instead of whatever it was in the other one, 8,000. And then give me my count distinct of accident ID rather. And so you can see that Tableau, like it's still calling this the sum of average daily vehicle sales, but this is a relationship, not a join. So in a join, Tableau matches the rows as many times as possible. In a relationship, that's not the case. Basically, think about it like Tableau already aggregated this number at that level, and the same for this one. So unlike a join, we're not seeing that duplication like, oh, this got summed 11 times because it matched that 11 times. That's not how joins work. Joins just use whatever field that you've got going on in your worksheet. So like in this case, location name, or I guess, we defined that back in the relationships dialog, and it just uses that. It basically says, well, the aggregated value from this table is 1,700 and the aggregated value from that table is 11. So you don't have to like You don't have to be like as on your guard of like, oh no, is it going to like duplicate these values? No, it's just relating them at that location ID level. And yeah, was this? I think this was related. I think we kind of talked about this earlier. So in the interest of time, I'm just going to glance over this one, but just think back to however long ago that was when we created the level of detail expression to fix on the location and get the minimum of the average daily vehicle traffic. Okay, another pro of relationships is that you're really only using the elements that you need for each sheet. So thinking back to the joins, we talked about that situation. Oh, you got 1,500 columns. This is a huge data source. Well, relationships don't work that way, right? So let me go to our restaurant sales and hours worked. I know I use this as an example for situations that relationships might not be as good at. I actually think it can work in this circumstance. We'll try it anyways. We'll try our luck here. So I've got sales and hours unioned here, and now I got to join it out, or excuse my language there. Whoops. Now I got to relate it out to these other tables. So we got items, we got stores, we got employees. So on kind of any given worksheet, I can just be like, right now, all I'm really looking at is hours worked. So I could just say like, okay, where's my store ID? There's my store ID. So if I find my store name maybe, or not, whatever. And then hours worked. So if I'm just digging into that, cool. What did Tableau have to do for this? Well, it basically just got data from 2 of those sheets. So it's not bringing in all those unnecessary fields from all those other sheets that I'm not using here. I don't have an extremely detailed example for this right now, but this can also be helpful for situations where you're like, yeah, I got several sheets. Sometimes they need to relate on this thing, sometimes on that thing. Cool, you have flexibility now where each sheet can have a little bit of its own data model if you want to think about it like that. Okay, so now to the cons list. One con of relationships, they have minimal ability to reshape a table before relating on that table. So what do I mean by that? Well, if I go into here, I've got a data set here. I've got my sample superstore again. So the transactions, broken out, one record for each transaction. I've also got what's called a state enrollment table. And this table is not really set up at this point to join very easily. So what it has is it just tells me for each year, for each state, how many people or customers or whatever did we have enrolled in our program. So unlike with a join, I can't be like, oh, okay, give me the enrollment and let's pivot that and get that ready to join. So if I go in here and then let's see if I can get this to play with me. If I prove myself wrong here, then I guess it'll just be a good teaching point on why you can do this. So I'm gonna go in here and say, you know what? As I'm doing this, I'm thinking that maybe this is possible. Maybe I was just doing it the wrong order before. So this thing's a little messed up. There's a couple things I got to do here. First of all, so I've got my year field, pivot field names. I want a state field, so I got to do a quick split here. Give me a moment to do that. Pivot field names. So this is going to be state. Side note, you actually can't use a calculated field in a join or relationship clause. So meaning I can't tell Tableau use this state field and then join it to the state field over here. So what I got to do, I need what's called a join calculation. So I'm going to edit this and just steal the logic behind this. Now I'm going to bring my orders table here. So how do I want to join these? Okay, there is a state field in orders, and that needs to join to that calculation I just came up with. And actually there's a year field as well. So this year, and I keep saying join, so just forgive me for my misspeaks here. This would also be a relationship calculation. It would probably be based on the year of order date. Okay, I think I just disproved this. Whoops, my bad. So I guess put this back in the pro column. Relationships can handle a little bit of reshaping tables, doing something like a pivot there before relating them. Yeah, I was going to say joins can do that too. You know, one of the limitations of Tableau desktop in general is you're basically limited to like a single pivot. So if somehow I needed to take like 2 different tables and pivot them both before relating them, you're out of luck with Tableau desktop. Join us for a Tableau prep webinar down the road. No, well, that is probably how I would handle it, or some other tool. Okay, so anyways, good news, we can do that. This is probably maybe the biggest con that I can think of with relationships. You may accidentally overlook unclean data because of that situation that we looked at, where you know, when you're relating them, unless you're using a measure from both tables, it's not necessarily creating an outer join. So to give you an example of how this could occur, let's see, which data source? Global Superstore. Okay. So in this data set, again, just another variety of Superstore. I've got my standard orders table, and that, again, just got a record per transaction. And then my people table tells me who's the manager of each region. So I've already kind of pegged this one mentally. There's a typo here. That region is not supposed to be AMEA, that's supposed to be EMEA, at least I'm pretty sure. So if I relate these and just say, yeah, well, you know, region is supposed to equal region, let's go. You know, I may end up doing all sorts of things here where I'm like, get back to the correct worksheet that I'm supposed to be on here. There we go. So depending on what fields I pull into this worksheet, I may or may not catch that, right? If I just grab the region field from my orders table, okay, so there's my EMEA, right? And then if I grabbed, where is that person? Because I'm just using a dimension from each table and I'm not using a measure, check it out. EMEA, it just drops because we're essentially simulating an inner join here. Now, if I was to pull a measure out, you know, if I did something like, oh, what was our total sales for each of these regions, it comes back because now, again, we're creating something more like a left join. But without that, I may have just totally missed the fact that I dropped a record. I dropped one of my regions. So you need to be careful about that. Unless you're using measures from all of the tables that you're pulling out, you may sort of unintentionally be overlooking the fact that there's a missing region. So in this case, I could go back there. There's ways of handling this. If I can anticipate this, if I know that's the case, I could do a calculation and I could say, okay, if region equals AMEA, then really it should be EMEA, else region. But if I didn't see that up front, then I could have missed that, right? So now, without the measure, it's pulling it in because I essentially kind of band-aided that in that join calculation, but I could have missed that. Okay, this is sort of an abstract one, handling nulls and calculated fields. At a high level, basically just to say, as I was doing experimentation, I noticed that the way that null values are handled in calculated fields differs a little bit between joins and relationships. And let me just pause to say this. I'm looking at this. I've got a bit farther to go. I think we're going to run over a few minutes. So if you have to drop, I totally get that. Like I said, we're recording this. We're going to hopefully have this up in the next couple days. So if you have to miss the conclusion or something, I'm sorry. I thought an hour would be enough. Apparently not even. But it shouldn't be much more than that. So if you have like a 5 or 10 minute, you know, flex here to be able to go into it, I don't think we'll go too far over, except maybe with questions or something. I'll stick around for some questions at the end. I know a lot have come through that I have not had a chance to address yet. If I don't get a chance to address you here live in the video, I'll try and follow up with you based on your questions as well. Okay, so I think in this case, we're going to go back to the chocolate and pub sales. And specifically right here, I'm going to be looking at the relationship variety. Okay, so why did I go to that one? Maybe I clicked on the wrong place. Okay, so I've got my relationship combining these two tables together. So something that I noticed is as I was trying to write a calculated field, which would basically allow me to combine the pub and the chocolate sales together. So actually a couple things. First of all, I've created a date calculation that just, if one date field is null, it swaps in the other date field. So I should be able to have just a single unified date. Without the measures, I think there's still going to be some gaps. Like notice November 12th is missing, but otherwise the dates are showing up. And then I've got a total sales calculation. And it's funny, I think as I was doing some testing, I wrote it this way first and this way second. And I didn't expect it to give me different results, but it did. So the ZN function, if there's ever a null value, it just replaces it with a 0. So my thought was, all right, well, whether you tell it to replace the individual row with a 0 or just tell it to replace, for some reason you added some numbers together and they came back as null. I mean, it seemed like it should be roughly the same. And so what I noticed with relationships is I do this, I put total sales on text, and any day where there was a record from one table but not the other, it was just showing up as a null. And I was like, okay, well, let me just try this calculation the other way. So let me comment out sum then Zn and swap this out for Zn and then sum. So hit OK, and that works. Now, one of the oddities of this situation that I probably should have pointed out is the totals were unaffected. It says this is a total of 189,000, and if I remember correctly, which is a big if, I think it gave the same number. It gave the same total here, but it wasn't showing some of those individual values, which was like, what is happening? So I don't know. My guess here is that it's basically Tableau using the relationships feature is relating based on whatever dimensional value is in the view. So the order that we utilize the aggregations in probably affects how these aggregations work and then how they relate to one another. I don't have that totally ironed out yet, but that's just kind of based on my observations. The funny thing was when I saw that and I was like, is that how that would work with joins too? So then give me a second here just to join these together instead, and I'll do an outer join. So I've got that. I think I've got my master date calculation already. And then total sales and totals. Okay. And I think in this case with joins, it did not matter what order that I put these in. So this is the one that was returning some blanks with relationships. I think I could have swapped those. Regardless, I think either way, this returns all of the values. So that is something to look out for if you're going to be writing calculations which reference any null values with a relationship. Keep an eye out for that and maybe try and test that both ways. I guess if you're trying to be safe, it seems like using the Zn function followed by the aggregation is going to give you more accurate results than the inverse. So I got a question while I was working on that, if this workbook will be available. Yep, I am planning on uploading this to Tableau, whatever, public. So you can download this again, hopefully by the end of this week. Okay, so that was my last walkthrough example. So let's just hit high level now on what have we learned? What are maybe a couple other things to be aware of? Couple other minor differences. So here's a few things where relationships are limited. And some of these are true of joins as well. And where this is true for both situations, I've tried to call that out. So first of all, relationships cannot relate published data sources, right? So if you have two different published data sources on Tableau server, just like you can't join them, you can't use relationships on them either. So you are stuck with blending, which we're not going to get into today. If that's something you want to know more about, let me know. I can follow up with some past webinars and resources we've put out on that. But that is a similar limitation to joins. Relationships are not available in Tableau Prep Builder. So here in Tableau Desktop, we have the option for relationships, but in Tableau Prep, you are still using joins and unions to be able to relate tables. That makes sense because these relationships are so dependent on the worksheet, right? And Tableau Prep can't anticipate what worksheets the data is going to be used in and how it's going to be related. So Tableau Prep is still effectively building a kind of physical layer or physical tables. Some of the same data sources that are limited that can't be joined still can't be related. So things like cubes and stored procedures is still limited on those. This is a couple notes where I didn't get as much time to do personal research on these, so I'm just more speaking to kind of looking at others' research, reading up from what Tableau had to say. Performance optimization is somewhat limited when using data source filters, relationships and data source filters. So like where we went when I added that filter that was like email equals username, if you're using that with relationships, some of the performance optimization that you might have been getting just by switching to the relationship, it might get cut back a little bit. I think it's because Tableau has to go back to the individual tables and try and do some filtering. And so I'm not saying that there's no performance increase, it's just maybe a little bit less. And then this one, I didn't really have a top of mind situation to show for this, but they did talk a lot in Tableau's documentation that relationships do not allow for circular logic, but the implication was that joins do. So I suppose if there's any sort of self-referencing in your relational clause, that's going to give you an error. Again, I don't have a top of mind reason why I would do some sort of self-reference, but if that applies to you, that's something to be aware of. Okay. So let's just look at a few quick things that how relationships differ than joins, not good or bad, just different. So one thing to be aware of is the count field. Tableau used to just give you a single field called number of records, which would allow you to just, you put that on text and you'd see, oh, this data set has 10,000 records. Count is kind of like number of records, but there is a unique count field for each table in your relational model, right? So in this case, you can see there's no number of records, but there are 3 different count fields. These fields are kind of inflexible. You can't change the aggregation on them. They're just count, and you can't reference them in a calculated field. But they are helpful for just saying how many rows is there in this table. You can always create your own number of records field from scratch too, by the way, just like I did that quickly in one scenario where it was just the number 1. Viewing data is a little bit different with relationships. So you can still see some summary level data, kind of like post relationship. But if you want to get down to like individualized records, it actually lists them by table. So you're able to say, oh, what data came from this data source that's on this visual and what came from this other data source. And where calculations are stored, I didn't quite nail this one down as far as like where they're stored. I'm sure there's a rule behind it. I just couldn't quite decipher what it was. So if you are only referencing a single field in a calculation or fields from a single data source, it's just going to store that calculation kind of along with the other fields from that table. However, if you are referencing multiple fields, I noticed that sometimes it got saved with the individual table. Sometimes it just got kind of saved at the bottom. Just even now, as I'm thinking about this, I think this is not an aggregated field. And then I think that this one is aggregated. So maybe that's the difference. If so this is still referencing multiple fields, but maybe the primary field or the measure or the first field was based on this table, so it got stored here. Whereas this was referencing multiple fields, but it was aggregated, so then it got dropped down there. That's kind of the best I could decipher it, but just something to be aware of. Unlike with a join where all the calculations get stored together, they may get stored with what table they belong to, or that the relationship thinks they belong to. Okay, so how are they similar, right? So there's quite a few things that are still similar between joins and relationships. First, they're trying to accomplish similar things. You're trying to relate rows of data horizontally. They have the same kinds of operators, at least in the newest version of relationships. They can each handle 2 or 10 or 20 tables. You know, I've never really seen an upper limit. Only just kind of practical, like that's too slow. They can use data source calculations, or basically what I did there to relate when there were some values that weren't relating. They both require fields to be the same type to relate on them. So like a string field has to equal a string field, for instance. They can both add secondary connections, meaning like, oh, you could have a primary connection to a SQL database and a secondary connection to an Excel workbook. They both can do that. And they both can create live connections, extracts, and they can both be published to Tableau server. So that's actually some ways that they are more or less the same. So what can we take from all this, right? Hopefully that was helpful to like see relationships in a lot more detail, see a bunch of scenarios where one, you know, joins might be better, or relationships might be better. So here's kind of the big takeaways. Where they happen, right? Joins happen up front. You define it once, it's set for the workbook. Relationships, you do some setting up front, but then it's defined at the worksheet level for the specifics. Relationships may help with performance. They might cut down on duplication. That might lead to less level of detail expressions, and that might also be a performance improvement. You know, relationships might help by not bringing in unnecessary columns, you know, into your data model. In some ways, they make relating data easier and more flexible because you don't have to be as concerned about data duplication. They're not as good for, in my opinion, they're not as good for exploring data or working with unclean data because in those circumstances, you might end up overlooking a value which you thought was going to match but didn't. And I may kind of amend this last point here. You might have a little bit more flexibility to kind of reshape tables in a join, but that pivot example that I was planning on using for that backfired. It turns out relationships could do that. I just missed it my first time through. So those are kind of some things to be aware of. Cool. So I've gotten a lot of questions. I'm going to take some time to go through those. Now that's kind of primarily what I have to share, kind of what I pre-plan to share. There may be more that comes out of the questions. If you have to run, or if you've already dropped off and you're kind of catching the end of this via recording, you're always welcome to shoot me an email with questions. So that's just eric.parker@onenumber.biz. In this workbook and in a blog post, which I'll create, which will accompany this, I'm going to link out to a bunch of resources, some of them from Tableau, some of them from other kind of third-party users that just had some helpful resources that I used to kind of get inspired for this and learn more about this feature. So you're welcome to start putting questions in the questions dialogue. I know I already have a lot to catch up with, so give me just a minute here to get a sip of water, review some of those questions, and we'll cover those as much as possible. Cool. Yes, I will make sure that I link out to some more details. There was a few different features I talked about. I talked about blending. I talked about row level security. I may even kind of send something about joins for anybody that just felt like, hey, we touched on that at a high level, but didn't get into it in as much detail. Got some questions about folks that have maybe been having personal experiences with joins that weren't working the way that they thought. So if anybody wants to follow up directly on that, maybe I can help troubleshoot that specific scenario. Hopefully I was able to answer this. One of the questions was about what are some of the input limitations that you can use for relationships. So like you saw, there was a few data sources like joins that still can't be related, something like JSON, stored procedures, but most of them have the ability to be related. It's very much a similar list to what can be joined. Hopefully I was able to speak to that one. There was a question, I saw that from you, Catherine, about what the view tab looks like for relationship data. So I think that's where I was saying, oh, you could look at the summary data or the individual tables. I got a question about unions, so I'll make sure that I send some follow-up on that as well. Real high level, just main difference between joins and relationships and how those are a little bit different from unions. A union, you're typically almost, you're relating tables of data vertically instead of horizontally. So it's like taking one table and stacking it on top of another table, more or less. So sometimes you'll do that if like, oh, this table is 2010 and this table is 2011 and I want to see them all as a single larger table. That's kind of a classic union example. Whereas what we've been looking at with joins and relationships is sort of saying this row is somehow also related to this row. Oh, that's a good question. Yeah. So can you, basically, can you do some joins and then some relationships? That's interesting. I think maybe. Give me a second here to try that. The reason I think that might be possible, actually, let me use the permissions example for that. Okay. The reason I think this might be possible is because you can do something like that with unions. You have two tables being unioned here at the physical layer, and then they are related at the logical layer. So, okay, if that's the case, let me bounce out of this. Let me remove this. So in theory, what I'm thinking of is, could I take sales? Can I go into the physical layer? Can I union hours worked? Can I join out to things like employee ID and items? And then could I bounce out of here? I've got my physical layer, and now can I relate that in a logical layer to my permissions table? I don't know if I've explicitly done this before, but it does look like that's working. So that's awesome, right? So maybe that's there are probably some circumstances where even that is a really helpful performance consideration, right? I might, because of the complexity of the unions and the joins, I might want to build this whole setup as a physical layer, but then I have the permissions, which generally would lead to data duplication. But if it's a relationship, then it wouldn't necessarily, because it's just relating at that level in the worksheet as opposed to duplicating rows of data. So thanks for that question, Sam. I think this is a great use case for where joins and relationships in a single data model. I'm just going to do a little renaming here so that when I end up sharing this out later, I know what it is, you know what it is. If you want to dig into it, you can. Let me just throw something from this data source onto this worksheet so that we actually know what data source it was that was used, at least. I don't even think it matters what it is. I think it's just, something like that. Okay, cool. Okay, yeah, just working through the backlog here. Okay, so since the data in a relationship is per worksheet, if you pull multiple worksheets in a dashboard, do filtering capabilities remain? Yeah, exactly. So that's one of the nice things about relationships as well, is it's all, from Tableau's perspective, well, it's all a single data model, even though it's changing a little bit, worksheet by worksheet, it's all coming from the same source. So if I had, 5 different worksheets using 5 different tables, but they're all part of the same relational model, I can have a single field like a store filter and filter on those with no ill effect. Should be able to kind of handle all of them. Yeah, here's a good question or a good comment, which is that their view is the primary benefit of relationships is that you can use a single data source to create some visualizations that require inner joins, others that require left, right, or outer joins, and the data sources don't have to bloat. They don't have to bloat like they would in a join. I think that's a good point, right? In a join, you are defining up front, inner, out, outer, right, and then later you can come back and filter. Whereas because the relationship's flexible, you can essentially mimic the different join types in different worksheets. So I think that's a good example of one of the where the flexible nature of relationships can be helpful. Somebody mentioned that maybe in table layout you could, if you had that situation like with the AMEA thing, that you might be able to get missing rows to show up. I know what that comment is referring to. I don't think that's the case here, but what the heck? Let's try it, right? So I could be wrong. So let's give this a go. So instead of joining on the join calculation, let me swap this back to the original region field where we lose the EMEA situation. And so the analysis, let's see, table layout, show empty rows. I was wrong. Okay, that's good to know. Thank you, Gustavo. I stand corrected. So it does look like there are ways of getting that to show up, although that will not be showing by default. So that's good to know that that toggle affects related data. I feel like I feel like you still have to have like a hunch that something is missing to even think to go turn that on though. But I'm super glad that you pointed that out because I was able to learn something as a result of that. So thank you, Gustavo. I appreciate that. I usually that's for situations where like, oh, there's a missing date in this date sequence and I want that to show up anyways. But that's good to know that it can help out in this kind of situation as well. Okay, good. Yeah, good question here about blends versus relationships. Yeah, so I'm for blending stuff. It's more than I want to get into today because we could probably end up doing a whole nother hour talking about that. So I'm going to kind of send some follow-up materials on blends. I'll link it out in the blog post, and then if it's something where you want to follow up on top of that, just let me know, and it's something that we can maybe talk about one-on-one. Yeah, so there's a question there. How do you increase performance while pulling data from the different databases? I mean, I think that's one of the key reasons that relationships exist, right? Is to help you see better performance. And I think I almost need a little bit more context to answer that question as well as possible, because there's also other considerations, like if you're seeing performance drag but it's on your local PC, maybe trying to create the data model in Tableau server would be preferable. So it's kind of hard for me to say for sure on that. But maybe that would help. Maybe trying to set the data model up in the server environment. Cool. Yeah, I see some people that are excited about being able to use joins and relationships together. Yeah, and I saw a question if is this the direction I think Tableau is going? I think so. I think I'll include myself in this as part of the initial wave that we're resistant to change, right? Where I was like, I don't know, like I'm just going to stick with the way that I do things. I'll be honest with you, I probably still will use joins a lot of the time. It may even still be what I default to, but in any type of situation where I'm starting to see any kind of performance drop off, this is going to be a really serious consideration of mine, right? Is thinking about the row level security example. I've got a client I work with where our data set is several million rows. It's probably up to like 8 million now. But if I created a row level security model the traditional way, I mean, the data source could be 100 million rows or more, and that's just completely impractical. So I think that there are a lot of situations, especially situations where data is duplicating, where this is going to become more and more sort of the thing of the future. And I think part of the reason that Tableau is moving this direction as well is they're just trying to create a tool that's as as friendly toward business users as possible. And I think that, short of like unclean data and needing to know where to find that, relationships require a bit less technical knowledge than joins and unions. You're just able to say, well, just show me the data that's related on store ID or employee ID or whatever that might be. So I think that that's sort of some of their mindset too. Um, how do we improve performance, and how do we retain the same level of information while making it more accessible to the average person? And so I think that's the effort here. So we'll see. I don't know what else they have planned as far as ways that they're planning to tweak this or advance this going forward, but they've advanced it a lot already. Like when relationships first came out, the only operator available was equal. So you couldn't say, oh, if this value does not equal, or if this value is less than or equal to this. So as I was trying to research what other kinds of limitations have people come across with relationships, a lot of things that people pointed out a year ago are already obsolete. So we'll see where it goes, but I think that they're trying to make this um, as usable as possible for as large of an audience as possible. Yeah. Cool. Yep. And then just some more commentary about kind of relationships plus joins, how some of that works. So glad we were able to cover off on that. Glad that question got asked. So I hope that I answered all of your questions. If I missed anything, please do let me know. Yeah, here's the email where you can reach me at. So I'll just stick around here for just a tad longer, but I think that's going to kind of largely do it for us today. So thank you for staying long. I thought I could do this in an hour, but apparently I couldn't. So I'm glad we at least had that long, and I really appreciate all of you staying through the end. I know that we went over a bit. So cool. Hopefully some learning here, and look forward to continuing the conversation via videos and blog posts and things like that going forward. So appreciate you all, and look for a link to this soon.